As you begin working in section 3.4, you will notice with this first example that it looks very much like the last one that you did in the video from 3.3. So we are finding a p-intercept, which is similar to a y-intercept, and it's also asking you what the r-intercept is. So that's the same thing as an x-intercept. So I have described for you here the process of how to do this. So the first one we're going to do is the p-intercept. So we have p is equal to, and we're going to plug everywhere we see an r, we're going to plug a 0 in. So 0 minus 4 times 0 plus 3 times 0 minus 2. And again, like as I warned in the last video, be careful with these and slow down and write this step in so you don't miss a sign somewhere. You're going to be doing this for something different at the end of this section, so slow down a little bit. So we have a negative times a negative, that makes a positive. You have 12 times 2 is 24. And again, if they want ordered pair points, you're going to have 0, 24 for this one. And for the r-intercepts, you're doing exactly the opposite. So you have 0 is equal to these three factors. So r minus 4, r plus 3, and r minus 2. And to finish solving this, of course, you set each factor equal to the 0 and solve. So each of these equals 0, and you solve. So you have one intercept at 4, 0. You have another intercept at negative 3, 0. And your last one is at 2, 0. Now, sometimes they won't want these as ordered pair points. They just want them as a list. So be sure that you read which one they want. So the next one they give you is similar to the last, but this one is not factored, and it doesn't need to be in order to find your g-intercept. So we're going to let all those x's be equal to 0 and solve for g. So we have g is equal to 4 times 0 to the 4th plus 32 times 0 to the 3rd plus 60 times 0 squared. And what's nice about this one is each one of those three gives you a 0 because 0 times anything is just 0. So this intercept will be at the ordered pair point 0, 0. Now, when you're going to find an x-intercept, you're going to be taking 4x to the 4th plus 32x cubed plus 60x squared, and you're going to be setting that equal to 0. So one way to do this, since you all don't have a calculator that's going to help you out much with this, is if there is a number that will divide every single term, then go ahead and do that to make your life a little easier. So I can divide this by 4, this by 4, and this by 4, and over here by 4. So I have x to the 4th plus 8x cubed plus 15x squared, and that's going to be equal to 0. That just makes my numbers a little smaller. So now I'm up to the point where I need to factor. So the GCF of this is, of course, x squared. I'm left with x squared plus 8x plus 15 is equal to 0. And I'm going to keep this in parentheses because that's the factor that we tend to want to overlook. So I will have that x squared out there. And then with the trinomial that's left, I have x plus 5 times x plus 3. And this gives me that x squared is equal to 0, I have x plus 5 is equal to 0, and I have x plus 3 is equal to 0. And once I do that, I'm just solving for the x. So for x squared, I just take the square root of both sides, so x is equal to 0, so it will hit the x-axis. And we already knew that because the y-axis was at 0, 0, so that also doubles as an x-intercept. The next one would be at x equals negative 5. And the last one would be at x is equal to negative 3. So another question that they're going to ask you is to tell you to use a graphing calculator to find all the real solutions, and it tells you to round to 2 decimal places. So what I've done is gone on to Desmos, and I have graphed this cubic function on here, and I zoomed it until I could see it all. So I can see from here that this is going to hit in 3 different places. So what I've done is given us 3 different pictures zoomed in for this. So I have the first 2 are here. So we can see from this one that I am at negative 1.45. That's one of my x-intercepts. And if it wants it as an ordered pair, you'll write it like that. Another one is at x is equal to 3. So that would be at 3, 0. And then the last one we had was here. and that would be at 3.450. So you just have to zoom in, make sure you can get 2 decimal places out of it before you type in your answer. This section also revisits long-run behavior, and the complication that it gives you here is not that it's all that complicated, but you have to understand that if you have this exponent out here, I'm going to rewrite that, it's a 2, so I'm not going to multiply all that out. Students freak out sometimes when they see this because they're looking at it thinking, do I have to multiply all those out? And you don't have to, because in the first one, this is t to the first. In the second one, this would end up having a t squared. And then in the last one, you would have a t to the first. So all you have to do is take this first degree, this second degree, and this first degree. So that's going to give me a total degree without having to multiply anything out of 4. So I know that I'm an even degree. So they have to go in the same direction. And then secondly, I'm looking at my leading coefficient. Now again, I don't have to multiply this out, but my leading coefficient is negative. So without writing the entire graph, I know that if I'm even and my leading coefficient is negative, then both of them are going the downward direction. So as t goes off into the negative infinity over here, my y values are going to go in this direction. So that would be negative infinity. All right, and similarly, as my t goes off into the positive direction this way, again, my y values are going to be going down, so this answer is a negative infinity. Another type of question they're going to ask you is to give you a graph, and they want you to write write an equation of the least degree in factored form. Now this is important because these are going to ask this in different ways. You have to make sure that you answer what it's asking for. There's a very specific way I want you to do this. So the first thing I want you to do is make a column for your x-intercepts. So I'm going to go left to right. The order of it really doesn't matter, but make sure that you get them all. So if I go left to right, my first one is at x equals -4. My second one would be x is equal to -2. My third one would be x is equal to 2. And my fourth one would be x is equal to 3. Well, under that circumstance, I would expect to have a 4th degree polynomial. So I check that. Both of these go in the same direction. So this is, in fact, my degree. So the least degree possible is 4th degree. So I'm going to make that note to myself. So when I finish this, I have to have 4 different factors. All right. So the next thing I'm going to do is come up with what those factors are. So in order to end up with x is equal to -4, the factor I had to start with was x plus 4. Because when I move that 4 over, that's where I get the -4. All right, if I have the x-intercept at x equals -2, and I pull that back over, I have x plus 2 would be my factor. Next one, if I move the 2 back over with the x, that would be x minus 2 on this side, and then, of course, x minus 3. Now, here we start to talk about something called multiplicity. Okay, so these all cut completely through the x-axis, and because they cut through the x-axis and don't just touch it, these will have a multiplicity of 1. Now we usually don't write these, so I'm not going to write that on this question because it's unnecessary. We will do another one where I show you this. So at this point, I have my function, f of x, I'll call it. They call it y of x at the bottom, so we'll switch it back over. I'm going to have x plus 4, x plus 2, x minus 2, and x minus 3. So we would hope that that is going to be our final answer. Now, the question is, are we sure that that's where I end up? So the way we have to check this is to pick this ordered pair point. In general, they use the y-intercept. It doesn't always have to be, but we have to make sure that this is actually where this is going, because I can make all kinds of equations that have those x-intercepts, but it doesn't have to look like this one. So this is where I have that a that we have been looking at when we were looking at our parent graphs with transformations and coming up with equations. That is still applicable here, even though this is a polynomial and not one of our parent graphs. So what I'm going to do is determine the value of a. So I'm going to plug this ordered pair point, 0, 3, in to this equation that we've come up with so far. So my y value is a 3. A is what I'm trying to find, and then everywhere I see an X, I'm going to plug in a 0. So I have 0 plus 4, 0 plus 2, 0 minus 2, and 0 minus 3. And this is where you're seeing that we were doing a minute ago with X and Y intercepts, okay? So this is a Y intercept, and now we are just making sure that we end up where we're supposed to be. And if we do, then A will be 1. That will happen from time to time. This is not a case where that's going to happen, though. So I have 3 is equal to. So here I'm going to have A times, I'm going to do 4 times 2 times negative 2 times negative 3. So I'm going to have 3 is equal to, so that's 8 times 6, so that's 48A. And then I have to solve for A by dividing by 48. And then I reduce that fraction. So A is going to be equal to 1 over 16. So this has to go into this equation to get to my final answer. So my final answer typed in online would be that A value of 1 over 16. And then I have X plus 4 times X plus 2 times X minus 2 times X minus 3. This is another equation that's asking the same thing. This time we have to talk about a multiplicity. So I start this process out the exact same way as we did the last one. So I'm going to have X-intercepts. I'm going to go from left to right. So the first one I see is that X equals negative 3. Next one, I have X equals negative 2. Now notice both of those cut through the X-axis. It goes from above to below and then below to above. Now when I look at the next one, I have X is equal to 1. Now notice, please, that this one hits the X-axis, but it does not yet go below it at that point. So this one is where we have to talk about our multiplicities, all right? So multiplicity, if it's not given to you, or you're looking at it and can tell that it touches the X-axis, then you are under the assumption that it has a multiplicity of 1. All right, if it cuts through, it could also have a multiplicity of 3 or 5 or 7. So these have to be odd. So I'm going to write 1 or 3 or 5 just to indicate that we know that it could be any odd exponent. All right, so since this one does not cut through, this one is even. So it's 2 or 4 or 6, and we'll determine which one we need in just a moment. So the last one I see is X is equal to 4. All right, and this one cuts through, so this is 1 or 3 or 5, okay? So at this point, we need to determine what degree I'm expecting to have. Now, according to this, it would be a 4th degree if I just looked at my X-intercepts. But as I look at this, I have that these are going in opposite directions, so I need to have an odd multiplicity. Now, in order to get an odd multiplicity, then I can take this to be a multiplicity of 1. I can take the second one to be a multiplicity of 1. This can be a multiplicity of 2, and then this could be a multiplicity of 1. So when I add those, I have 2, 3, 4, 5. So that would be a 5th degree polynomial. All right, the second thing I need to check is to look at my turning points. So I have 1, 2, 3, 4. So I need to add 1 to it. So as long as my degree is 5th degree, then we have the appropriate multiplicities. All right, so now we're going to take those and we're going to write out our factors. So go over one more column. So we have our factors. So the first factor, if we have X is equal to negative 3, then the factor would be X plus 3. Now, with a multiplicity of 1, I do not write that degree of 1. I just know that it's there. All right, next one, we have X plus 2. And again, multiplicity of 1, so I don't need to write an exponent up there. It's understood to be a 1. On the next one, I have X minus 1, and it has a multiplicity of 2. It's important not to forget that one because that will change the rest of your answers. And then last but not least, we have X minus 4. So at this point, we have a function where we're not sure what A is yet, but we have X plus 3, X plus 2, X minus 1 quantity squared, and then we have X minus 4. So I go back to my diagram and I say, okay, do I have an ordered pair point to check? So if I look right here, I have the ordered pair point 0, 1. So we are going to go through and check to see if A is something other than 1. So I'm going to plug a 1 in right here, and everywhere I see an X, I'm going to put a 0. So I have 0 plus 3, 0 plus 2, 0 minus 1 quantity squared. And again, if you leave that squared off, A is going to be wrong. So then we have 0 minus 4. So as I look at these, I have A, and then I'm doing 3 times 2 times negative 1 squared, which makes that positive 1, and then a negative 4. So I have 6 times 1 times negative 4 is negative 24A. So A is equal to negative 1 over 24. And this number needs to be put right there to get our final answer. So our final answer for this question is f of x is equal to negative 1 over 24, and then I have my factors. X plus 3 times x plus 2 times x minus 1 quantity squared times x minus 4. So the other 3 examples I have to do with this are doing the exact same thing, but now I do not have a diagram to look at. They just give me information. So I'm given that I want to write an equation of a polynomial with degree 5. So I have to make sure that I take that into consideration, that when I finish it has to be a 5th degree. It's telling you that your leading coefficient is a 1. What that means is A is equal to 1, so we don't have to go find it. So this question is a little bit quicker because I don't have to go check that. All right, so next thing we have are roots or intercepts. So I have roots of multiplicity 2, so I'm going to do 2 columns, multiplicity and x-intercept, or root, whichever way you want to label it. So I have multiplicity 2 at x equals 4. I have multiplicity 2 at x equals 0. And I have multiplicity 1 at x equals negative 5. So when I'm looking at my factors, I have to put those 2 columns together. So for the first one, I'm going to subtract 4 over. So this is x minus 4, and it has to have a multiplicity of 2. Next one, if I subtract 0 over, it's still just x. So do not write x minus 0. Just do x, and then that is a multiplicity of 2. And then for the last one, we're going to have x plus 5, and it is multiplicity 1. So my final answer for this one, because I already know that A is equal to 1, are these factors. So I'm going to do x squared first just because it's smaller. I'm going to have x minus 4 quantity squared, and then I'm going to have x plus 5. So that one was a little easier. We didn't have to check A because it gave it to us. The next example is doing much the same. You have an equation of degree 4. You have roots of multiplicity 2 at x equals 1. So I'm going to have my x-intercepts. X equals 1, and it has a multiplicity, I'm going to abbreviate, multiplicity of 2. And then we have roots of multiplicity 1 at x equals 0 and at x equals negative 2. So my factors then that I come up with are x minus 1 quantity squared. Again, x minus 0 we just write as x, so that's x to the first power this time. And then when we move negative 2 over, you have x plus 2, and again, it has an exponent of 1. Now, at this point, we have an ordered pair point that looks like this. It's not a y-intercept, but it still works the exact same way. I just have an x and a y value. I do not have any zeros. So I have f of x is equal to a, which I have to go find, and then I have x minus 1 quantity squared, and x plus 2. So I will be substituting the highlighted ordered pair point in. My y value is 112. A is what I'm trying to find, and everywhere I see an x, I'm going to substitute in a 5. Don't forget your exponents, because if you do, that's going to cause problems later in the problem. So I have 112. I have a times 5. Then I have 5 minus 1 is 4, and 4 squared is 16. And then I have 5 plus 2 is 7. Then I will have 112 is equal to 560A. When I divide both sides by 560, I'm going to end up with the reduced fraction of 1/5. So this goes in here for my final answer. So final answer would be f of x is equal to 1/5 x times x minus 1 quantity squared times x plus 2. The next one is very similar. This one's smaller. You have a degree of 3. So if you get good at these, you don't have to do the columns. I'm just going to continue to do them for those that may need to see the steps, and that's perfectly fine. If you need to show that every time, please do so. So I have root of multiplicity 2 at x equals 1, and root of multiplicity 1 at x equals -5. So at this point, I have f of x is equal to, so when I move my 1 over, I have x minus 1 quantity squared, and when I move my -5 over, I have x plus 5. And then I have an a value here. Now this one says that my y-intercept is at y equals -2. Well, that means I have the ordered pair point 0, -2 has to be on this equation when I graph it. So that's the ordered pair point I'm going to use to solve for a. So I have -2 is equal to a, and everywhere I see an x, I'm going to plug in a 0. And then we reduce, so I have -2 is equal to a. This is -1 quantity squared, which is 1, and then I have 0 plus 5, which is 5. So I have -2 is equal to 5a. So a is equal to -2/5. So this ordered pair point has to go in right there for your final answer. So your final answer will be typed in as f of x is equal to -2/5 times x minus 1 quantity squared times x plus 5. One more example for you today.